Good morning, it's Mr. Crouch. We're looking at Momentum Physics 12, and this is the second type of question. It involves one object hitting another object, and if they're identical and kinetic energy is conserved, they'll move off at 90 degrees to each other. So in this situation, one object will hit another object, and they'll move off in different directions. This particular question comes from the Glencoe textbook, the big one that is, Principles and Problems, and it's on page 243 and it's number 24. So we'll write it down right here, right now. I'm ad-libbing a little bit, changing the words a little bit to the problem to make it a bit more understandable. But a stationary billiard ball, now that's not like a pencil or a stapler or anything. We're talking stationary, not moving. That billiard ball is stopped. That's what stationary means. And it's struck by an identical ball moving, and I'll say it's to the north at 4 meters per second. And what happens is this ball, the identical ball, ends up moving off in one direction, and the stationary ball moves off at 90 degrees to that direction, as we'll see coming up. So changing a few words but keeping the same meaning. After the collision, M1, which is the first ball, so we'll call this one M1, moves at 60 degrees west of north, and M2, which is the ball that hit it, so this is M2 right there. It's the moving ball in the first place. It moves off at 30 degrees east of north. So they're 90 degrees from each other when they leave. After the collision, that is. The question, what is the velocity after the collision of M1 and M2? Because it's a collision, you'll have to use the law of conservation of momentum to solve it, and we'll do that right now. Work through it. The initial momentum of both balls have to equal the final momentum of both balls. The initial momentum is just the second ball traveling to the north at 4 meters per second. And then after, whatever the final total momentum of ball 2 and ball 1 are, it has to equal whatever this initial momentum is in the first place. We get a situation that looks like this. After the collision, we have M2 going off in this direction, and then we have M1 going in that direction. What we do know is that the momentum in this direction plus the momentum in that direction will be the final momentum. And that has to equal whatever the initial momentum was of both objects together. So let's make this a momentum triangle. The law of conservation of momentum. Initial total momentum equals final total momentum. Getting what the initial total momentum is, it was only from M2 because M1 wasn't moving, and M2 had a mass of 0.17 kilogram, had a speed of 4 meters per second to the north, and when you multiply the mass by the velocity, you get 0.68 kilogram meters per second. So that's the initial total momentum. It's moving to the north at 0.68 kilogram meters per second. So the initial total momentum is 0.68 kilogram meters per second. And the final momentum of M2, which is in that direction, plus the final momentum of M1 have to equal the initial momentum. So this one plus that one will have to equal this one. So final plus final have to equal the initial. Draw in the momentum of M2 final, and it's in that direction, but we know that they're at 90 degrees. So this one's going at 30 degrees, this one's going at 60. It'll be in that direction. So I have to draw at 90 degrees that one, which is P1 final. So right here is P1 final, P being momentum. And you may be wondering, well, how do you know that they're at 90 degrees? Well, we've got this one, P2 final, which is that mass going in that direction, at 30 degrees. And right where that vector ends, so right where P2 final ends, if I was to draw a north-south line just like this one would be off at 60 degrees. And if that's north-south and that's north-south, that angle is 60. This is an alternate interior angle. That has to be 60 degrees as well. If that one's 60, that one's 30, and 180 makes what you have total in a triangle. This one has to be 90 degrees. Cleaning the diagram up a little bit, I've got a momentum triangle, which is the vector triangle showing the law of conservation of momentum. It says the initial total momentum, which is up to the north, is equal to the final total momentum, which was m2 going off in that direction plus m1 going off in that direction. So all we need to do is find out what P2F is and what P1F is, and we, since we have 90 degrees there, can use just normal trigonometry or just Pythagoras. So let's do that. Find P1 final, which is the momentum of the ball 1 final. I just have to use one of the angles. I'll just use the 30 degrees. I could have used the 60, but I'll just use one angle, 30 degrees. Call this one the opposite side, right here. This one is the hypotenuse side, and then this one must be the adjacent. Sine theta will be opposite over a number I know. This is 0.68 right here. So that is the way to go for sure. So I've got sine 30 degrees is equal to something I'm looking for, P1 final, over 0.68. That hypotenuse is 0.68. It's in kilogram meters per second, so my P1 final will be in kilogram meters per second. It will be a momentum. I get P1 final is equal to 0.34 kilogram meters per second. Now I'm not looking for just the momentum. I'm looking for what the velocity of M1 is. So you just have to remember that P1 final is equal to M1 V1 final. So I've got P1 final, it's 0.34. I've got M1, and I just need to find V1 final. So I'll just do a little bit of algebra right now. And just working it through, 0.34 is equal to 0.17, which is M1, times V1 final. So V1 final is just 0.34 divided by 0.17. Speed for ball M1 of 2 meters per second. And remember, that is at 60 degrees west of north. So this guy right here is at 60 degrees west of north. Now we're trying to find out what the final speed, final velocity actually, of mass 2 is. So we're trying to find this vector right here. And to find it, we've got the hypotenuse, we're looking for this side, we've got the angle. So just cos 30 is adjacent over hypotenuse, which is adjacent P2F over the hypotenuse, which is 0.68 kilogram meters per second. Remember, if we keep the units as kilograms and meters and seconds, our final velocity will end up being in meters per second. So we've got cos 30 is equal to P2 final over 0.68. And just checking my trigonometry, cos A, yeah, Ka, C-A-H. Got it right. Up here, I don't want cos 30 as P2F over 0.68. I just want to get P2F on its own. So the final momentum of the second object. So I have to multiply this side by 0.68, and I have to multiply this side by 0.68. So I get 0.68 times cos 30 is equal to P2 final. 0.5889 kilogram meters per second is equal to P2 final. And remember, P2 final is just M2 V2 final. And we're trying to find V2 final. So this whole thing right here is equal to M2 V2 final. That we're trying to find. We already know that M2 is 0.17 kilograms. So we'll solve this up here. We know that 0.5889 is equal to M2 V2 final. And we know M2, it's the same as M1. And just to confirm, it's 0.17 kilograms. So 0.5889 is equal to 0.17 times V2 final. And just do the algebra. So divide this whole side by 0.17, divide this side by 0.17, and you'll have what the final velocity of ball 2 was after the collision. And doing the calculator work, we get 3.46 meters per second, and it is in a direction of 30 degrees east of north. So at 30 degrees east of north. So north, 30 degrees east of it. And that is the answer.